Okay, so we're going to start off with the homework over the alternating series where we determine if it is absolutely convergent, conditionally convergent, or it is divergent. Okay, let me find that picture of your homework paper there. I think this is it. Yeah, there we go. Okay, and so question 1, it says determine if the following converge absolutely, converge conditionally, or diverge. And the first question is the summation of n equals 1 to infinity of -1 to the nth all over n. Okay, so we see quite a few things going on here, and we've got a lot of tools in our toolbox now that we've done extra videos that I told you there would only be 2 and there were 3. So you can tell that it's an alternating series. However, this is asking us if it is absolutely convergent, conditionally convergent, or if it's divergent. So we need to start off with that first part of doing the absolute convergence, where we're looking to see if it's going to be absolutely convergent, and that's by looking at the absolute value of that series, okay? So the first thing I like to do is we're going to start out and we're going to list a few terms in the series. So if I put 1 in there, that's going to give me -1 over 1, okay? If I put 2, that's going to give me plus 1 over 2. If I put 3, that's going to give me -1 over 3. If I put 4, of course, that's going to give me plus 1 over 4, and it's going to keep going. If I take the absolute value of that, okay, that's going to give me, those values I'm going to get there now are going to be 1 over 1, plus 1 over 2, plus 1 over 3, plus 1 over 4, and so forth, okay? Well, what does that look like? That actually looks like something of a p-series. It looks like the summation of n equals 1 to infinity of 1 over n. You agree? Because if I put 1 in there, I get 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 and so forth. That's what I'm getting. Okay, so this is a p-series. What does p equal here? Well, in this particular case, p equals 1, which means that that series diverges. So all that tells me is, since the absolute value of the series, diverges, so the series is not absolutely convergent. But it can still be conditionally convergent. Okay, you just said it's not absolutely convergent. Okay, so if we're looking at if it's conditionally convergent, I need to determine if the series itself is convergent. Okay, so I'm back to looking at the summation of n equals 1 to infinity of -1 over n all over n. Okay, it is an alternating series. Okay, so alternating series, which means there are 2 criteria that need to be met. But the first thing I have to do is I have to take out that alternating chunk. I have to take out the part that makes it alternate, which is the -1 to the n, and I have to find a sub n. So in this particular case, a sub n is going to equal 1 over n, because that's what's left once I remove the part that makes it alternate. Okay, so now I'm going to take the limit as n approaches infinity. That's my first one. It's my first step. And this is actually what? This is actually pretty much the divergence test here. Okay, so it has to meet this criteria. So I've got the limit as n approaches infinity of 1 over n. That does equal 0. Okay, and then the second one is, does a sub n plus 1, is it less than or equal to, I know that a sub n plus 1 has to be less than or equal to, I believe, hold on just a second, is it equal to? See, I've got too many things going on here. Oh, well, I'm not thinking. Sorry, Harley. Yeah, less than or equal to a sub n. Okay, so let's check it out. I've got 1 over n plus 1. Is that going to be less than or equal to 1 over n? Yes, it is, because that if I put in 1, I'm going to get 1/2 is less than or equal to 1. Yes, and that's going to keep going because that denominator is larger on the left-hand side than it is on the right-hand side, and that n plus 1, which makes it smaller because 1 is my numerator. So that means since both of these criteria are met, then it is going to be conditionally convergent. Okay. Okay, so number 2, I have the summation as n equals 1 to infinity of -1 to the n plus 1 times n over 3n minus 1. Well, okay, so once again, and I may need to move this down. Let me see if I can move that down a little bit for you so I've got enough room. I may can move it back up in a minute. Since we're going to check for that absolute convergence first, we need to deal with the absolute value of it. So the first thing I'm going to do is I'm going to write out a few terms. If I put 1 in there, that's going to give me, well, -1 squared is 1 times 1 all over. If I put 1 there, 3 minus 1 is 2. Okay. If I put in 2, that gives me a -2 over 6 minus 1 is 5. And since it appears to be alternating, we're figuring the next one is probably going to be a plus, which it is because -1 to the 4th is positive. Makes a positive 1, and that gives me 3 over 8. And so we see that alternating series happening. So what that means is when I take this, I get n equals 1 to infinity. It's pretty much like it's taking out, let's go ahead, I'm going to write it. We're doing the absolute value there. I'm not sure I understand. Oh, sorry about that. Siri's been talking to me all day. I don't know why. He's a little upset. Or she is. When I take that absolute value, it's kind of like removing that alternating part, right? Because we're making everything positive. So this is the same thing pretty much as the series as n equals 1 to infinity of n over 3n minus 1. Now here's where I'm going to use that nice little divergence test that I talked about, where I can take the limit of a of n, because I have now determined what a of n is. We're saying that a of n equals n over 3n minus 1. I can take that limit, and if it doesn't equal 0, then I know it's going to diverge, okay? So n approaches infinity of n over 3n minus 1, and that's going to equal 1/3. That does diverge. But remember, we're just checking the absolute value part, which means that this series is not absolutely convergent. So, which means not absolutely convergent. Okay. So now I need to check on the conditional convergence. Okay, so I take the series itself, n equals 1 to infinity of -1 n plus 1 times n over 3n minus 1. Okay, that is an alternating series. What's the first thing I do? I take out the chunk that makes it alternate, which is that -1 to the n plus 1. That tells me that a of n is going to equal n over 3n minus 1. Now I'm ready to take the limit of that. So I take the limit as n approaches infinity, because remember, it has to meet two criteria. It has to meet both. If it fails to meet one of them, we don't have to do the other, of n over 3n minus 1. We find that does equal 1/3, okay? It doesn't equal 0, so it is, it diverges, which means that series altogether is divergent, okay? Because we got, when we tested the absolute value, it was divergent. When we tested the series itself, it was divergent. So that means it is neither absolutely or conditionally convergent, which means the whole series is divergent. Okay, number 3.
I found this on the web.
Number 3, I'm going to scoot number 4 down here. And we're only going to work through 1 through 4 on this video. I'm going to bust it up a little bit. So number 3 says, I've got the summation of n equals 1 to infinity of negative 1 to the n plus 1 over 3n minus 1. Okay, so we're still dealing with absolute and conditional convergence along with divergence. So I'm going to start off, same old, same old. I'm going to write out a couple of terms. If I put 1 in there, that's going to give me a positive 1 over 2. If I put 2 in there, that's going to give me a negative 1 over 5. If I put 3 in there, I'm going to get a positive 1 over 8. And you see it alternating. Okay, so let's take that absolute value. If I have my series and I take the absolute value of it, negative 1 to the n plus 1 over 3n minus 1. I take the absolute value of that what was causing the alternating to occur, that plus minus to occur, when I take the absolute value of it, it's just going to become positive. It's going to become positive 1. So this really winds up being the absolute value of, not absolute value, I'm sorry, the summation of n equals 1 to infinity of 1 over 3n minus 1. Okay, I'm going to need to take the, I'm going to need to determine if that's convergent or divergent. So what I'm going to do for my absolute convergence, I'm going to use my divergence test. Okay, and let's see what that's going to give me. I've got the limit as n approaches infinity of 1 over 3n minus 1. And what's that going to give me? That will wind up giving me 0 when I take that limit. Of course, we did say on the divergence test, if we get 0, that could still mean that it is convergent or divergent. Okay. So let's go ahead. We're thinking it probably can be absolutely convergent here. Okay. But we are not certain of that. And my whole computer went down over here. That's interesting. Okay. Let's deal with that alternating series part for the conditional convergence. I have the summation of n equals 1 to infinity, of course, of negative 1 to the n plus 1 over 3n minus 1. If I remove that alternating portion, a to the n is going to equal 1 over 3n minus 1. We need to get both of those. This has to meet 2 criteria. Both of them have to meet. Of course, we have that limit as n approaches infinity of 1 over 3n minus 1, which we know that equals 0. Okay, our other one is, will a sub n plus 1 be less than or equal to a sub n? So that says, will 1 over 3 times n plus 1 minus 1 be less than or equal to 1 over 3n minus 1? That's going to give me 1 over 3n plus 2, and that is less than or equal to 3n minus 1. It is true, because the side on the left is going to produce a denominator that is larger than the one on the right, which makes that 1 divided by that larger denominator a smaller value. So that is correct. So we are going to say that this is absolutely convergent. I may come back to question 3 when I get through with all of the problems, because I would like to address that absolute convergence on that first chunk. I don't really like leaving it as is like that when we have the form of, yeah, it may be, it may not be. I don't like that. I am going to call it, though, as absolutely convergent. But like I said, I need to come back by and see what happens with that. Okay, let's look at number 4. Okay, and I'm pretty sure I can fit that in here. I may need to scoot him down a little bit. Let me scoot him down a little bit. Okay. I have the summation of n equals 1 to infinity of negative 1 to the n plus 1 times n squared all over n squared plus 2. So I'm going to start off with that absolute convergence again. We're going to test that absolute value there. So if I put in 1, that's going to give me a positive 1 on top over 3. If I put in 2, that will give me a negative 4. Okay, because 2 squared is 4. That gives me a negative 1 over 6. And you'll see that's going to alternate. So that means when I take the absolute value, I'm really looking at the summation of n equals 1 to infinity of n squared over n squared plus 2. Okay, so we can do the divergence test on this. Okay, that's going to give me the limit as n approaches infinity of n squared over n squared plus 2, which equals 1. Since it doesn't equal 0, that gives me a divergence right there. But remember, all I was doing was testing for absolute convergence. So here we say not absolutely convergent. Okay, so now let's try to see if it's conditionally convergent. I have the summation of n equals 1 to infinity of negative 1 to the n plus 1 n squared over n squared plus 2. Of course, we remove that alternating chunk, so that tells me that a sub n is actually n squared over n squared plus 2. And we have, if I take the limit of that, which you have already done, we have to meet our 2 criteria. I've got the limit as n approaches infinity of n squared over n squared plus 2. That winds up equaling 1. I don't have to test the other. Okay, so that shows a divergence right there, which tells me that the series itself is divergent. Okay, and that is 1 through 4. I'll pick back up in part 2 with 5 through 8.